In red here is a selectable marker. All plasmid vectors should have a selectable marker. Usually, it's antibiotic resistance. So we're going to call this one CAN-R. That stands for kanamycin resistance. That allows the bacteria, the successfully transformed bacteria, to grow on kanamycin plates. Now, it doesn't tell you whether your insert has assembled correctly or not, but it does tell you the bacteria has taken up the plasmid. And that's the lowest efficiency step of any transformation. It's something like 1% of the cells will correctly take up the plasmid. So if you don't have this selectable marker to choose from them, and you just spread them on a non-selective plate, then 99% of the colonies you're looking at will be unsuccessful transformants. So you have to make sure that you have a selectable marker, otherwise cloning becomes unfeasible. It's also worth noting that these are an evolutionary pressure that really help you maintain your plasmid. Because usually in synthetic biology projects, you're trying to make the cell do something that it doesn't normally want to do. And if it doesn't normally want to do it, it's probably not good for its survival. It's probably quite stressful. So the cell will try and kick the plasmid out, unless the plasmid does more for the cell that is good than it does bad. And the way we normally achieve that is through this selectable marker. So if I'm growing up in the kanamycin plate, but I'm also making the cell express a protein, which is a burden to itself that it doesn't really want to do, if it kicks out the plasmid, it dies because the kanamycin kills it. But if it keeps the plasmid, it just experiences a bit of stress. It grows a bit slower. So one thing to note with your selectable marker is to always grow your cells on the correct antibiotic. And even once you have your selected cells that you know have the insert, you still have to grow them on the antibiotic because otherwise they may kick your plasmid out.